at no point in time together into one framework. You can bring all the three tables together, and then you can extract the user interface, user interest, and implement that into all those user profiles which are your premium customers on the fly, right? You don't have to do any ETL, operations or none of the batch processing. You can do on the go. So that's the power of what the NoSQL and the Spark can do together. And there are a lot of use cases in terms of operational analytics or the machine learning perspective. Like for example, you have your online shopping recommendation, where when you get huge points of data from the different purchases, or even how a customer moves from one page to the other, and though while shopping, there are a lot of analysis which happens at the back end which are not visible to us, like where we can identify what coupons can we give for the user in order for him to complete the purchase, so we don't lose a new buyer, right? Or in real-time span classifiers in the communication apps, right? For example, in emails, it automatically, as it comes, we can identify what are your spam and non-spam mails. And then from the predictive analytics from the playlist, like based on the user profile, what kind of music he likes, we can give a real-time recommendation of what music he would like, and of course in the fraud detection models. So we have several use cases from the integration perspective and the machine learning perspective. So over to this, I will hand over to Nishant. He'll talk more from the natural language perspective. Thank you.
Thank you so much, John. I'll just get the PowerPoint very quickly so that I can move around. This is working now. Meanwhile,
Hello.
since we have about 30% people who have attended the session yesterday, which was more on the overview, what I'll do is I'll err towards on the side of caution and do touch a little bit in terms of intro to NL, and then very quickly get into the specifics of things. Okay, great. Audible? Cool. Thank you. So, what we'll do is we'll very quickly touch on the intro and, look only at the vector models, which is quote unquote the deep learning models. It may or may not be deep depending upon the implementation, but as far as the theory goes, if you want to, you can, implement a deep version of that. And then we will, take a use case, which is an intent identification use case, and then, beat it to death, hopefully. Very quickly, natural language understanding. Basically, what happens is you and I, we are talking. We have genetically been modified to have conversation and understand what each other is saying, even if we do not understand language. So, for example, you don't know Mandarin and you land into Beijing, and you may still use some language, sign language, body language to communicate, and those are the elements of how humans have evolved. When we convert natural language to a system where computer starts getting meaning of the language, that is called taxonomy. Taxonomy is a big graph where what basically happens is you are giving meaning to a word so that basically computer understands. In technical terms, it's called DAG, directed acyclic graph, and the meaning can be as is meaning, or rather is a meaning. For example, cipher is a conference, January is a month, Bangalore is a city, and you know, computers love to have such a very simplified relationship, and as long as you have that, then you can build linear models and be very happy about it, right? Then there can be what we call hypernyms and hyponyms. Hypernyms are essentially words which have very large meaning or very broad meaning. Color is red, so many colors, you know, one of them is red. And a hyponym is one, you know, words which may have multiple meanings. Depending upon the context they are applied and so on and so forth. So, you know, that is where, you know, things start becoming murky for computers to start scratching their heads. Oh my God, what do I do? Do I go here? Do I go there? Right? That's where your model starts saying, you know, 50% probability, you know, toss a coin and you can have that intent or this intent. That's pretty much, that's, you know, this thing. Now, typically, some problems in natural language understanding, you know, very quickly, information extraction is one of the problem which we right now love a lot. You know, hey Siri, schedule Cypher conference at 9:15 tomorrow morning, and Siri is intelligent enough to extract the relevant pieces in your conversation to book your appointment, right? So that is a problem which is, you know, I wouldn't say fully solved, but is still, you know, very much evolving and an area of active research. Then there is sentiment analysis. Who said what to whom, you know, how did they say it, you know, nicely, not nicely, you know, typically how we kind of put sentiments in, you know, some buckets like positive, negative, neutral, things like that. Context summarization. You have, you know, one section or one document, and the document may have multiple context. So, you know, a document or a natural language page, a web page, for example, may talk about you know, if I pick, say, recent news, right? So, so a recent news might be, you know, some events which occurred in our city, which is, you know, for example, you know, writing and things like that. But you know, there was another event which was water-related event, two independent events basically coming together, right? And so if I want you to summarize, you can summarize, you know, you just want to summarize water-related issue and do not want to summarize the other issue. And so that can be contextual summarization. You pick out a context which is one level of classification, and then you know, create a concise summary of that. Classification as a use case, we will talk about this in further detail. You know, you have one word, one document, one web page. You have to basically say, what is this about? And that would be the classification part. Machine translation, you know, it used to be an area of big research, and you know, Google pretty much came and killed all the excitement out of it. They got it right, and they got it accurate with such a level that you know, human translators started losing their jobs. So you know, that is one place where natural language has been applied to very successful this thing. Topic modeling, you know, given a document or given a set of documents, can you identify what are the n different topics people are talking about? Very, very exciting area when you have you know, people in chat or Quora talking about so many different topics that you can't really get your hands around. And Quora needs to, you know, you go there and you say, hey, you know what? I want, I'm a travel blogger and I just want to talk about travel. And Quora doesn't have somebody sitting over there basically, you know, annotating every story or every question coming in saying that it's travel. They have to do it automatically, and that is really what topic modeling is. And then finally, you know, you have entity extraction, whereas you identify nouns, pronouns, person, place, animal, thing, companies, organization, you know. Somebody wants to know what they are talking about for a particular organization. That is basically entity extraction. So, so what we will do is we will jump into the vectorized model of things. So basically, what we do is we, you know, we have. I'll just quickly set things in context. So, you know, if I had this one sentence, the cat sat on the mat, this is a very simple sentence, and I need to make, for example, a vectorized model out of it. The few things which I want to touch about before this is, you know, we will use a software called Word2Vec, or the concepts in that to create a